So we'll begin with the nominal level. So here is a quick definition. So a variable is nominal or at the nominal level if its values are simply names or labels that we are applying to a qualitative feature that we're using to distinguish a qualitative feature. Okay. So for instance, if we're looking at all these shoes, you can tell that their color is different. Well, the color is a typical nominal variable. Why? Because it just describes a qualitative feature. Red is just the name of a color, so is black and so on. So there is no quantity involved in it, just a qualitative feature. When we look at different people, we can often distinguish them by their ethnic origin. And so the ethnicity of a person is also a quality as a name or a label that we assign to a person. When we look at flags, for instance, some of the things that we can do is we can check if they have certain graphical features. So the presence or absence of a graphical feature can be a nominal variable as well. Now, the key point about a nominal variable is that its values do not have a natural order. There's no way in which we can order the possible values in a way that makes sense. It is some kind of natural. It's not artificial. It's not imposed. It does not violate some kind of basic requirement. So that is really what is important about the nominal level. For this reason, nominal variables are also called qualitative or categorical. Qualitatives because they describe qualities, categorical because they really identify the objects we're observing as being in certain categories or other categories. There is a particular type of nominal variable that is used very often, and are the ones for which only two values are possible. And these are called either binary, which means two values, or dichotomous, means cut in two. So there is only two options. The yin-yang symbol is a very good mnemonic for this kind of idea. There is only two possibilities, in this case red or yellow. Okay, so this is even though it's a very simple kind of variable, it's very important because, for instance, encompasses situation. What you're looking at is something where you're going to ask a question and you're looking whether the answer is yes or no, or you're checking the statement, a certain statement or a certain question. You're trying to find out if it's true or false, or a patient, you may want to know if that patient is alive or dead, or if the patient is female or male, or if a certain treatment is a success or failure. Oops, too fast. So these are all dichotomous variables. So these kind of variables are going to be very common, and we're going to use them quite a bit. We are now go up one level to the ordinal level of measurement. Now, in the ordinal level of measurement, the values do have a natural order. It's easy to figure out which one is lower, which one is higher, which one is less, which one is more. But this order, these different values are not obtained through some objective measurement done through some kind of an instrument. Okay? Some basic examples, and then you'll see some more in class. Things like subjective scales, things like pain scales. Okay, on a pain scale, where are you right now? On the smiley face or the crying face? Okay, again, smiling is better than average is better than slightly sad is better than in pain, right? But can we really measure with any accuracy what these things are, what the level is, what the value is for those for each person? Now, sometimes these things are associated with some numbers. So for instance, in this situation, we might associate the number 0 to the smiley face and the number 10 to the crying face. But these numbers are purely arbitrary. A related thing, what do those numbers really mean? What are we measuring with those numbers? A very related situation is with something called the Likert scale, or you may have heard it called the Likert scale. People mostly call it the Likert scale, although the correct pronunciation is Likert. And that is when you're trying to ask someone, do you strongly agree, or neutral disagree, or strongly disagree with the following statement? Again, this is just there is a natural order from strongly disagree from strongly agree to strongly disagree, or the other way around. But there is really no way of measuring exactly. Again, quite often you're going to find that there are numbers associated to these values, but these are arbitrary numbers. Why 1, 2, 3, 4, 5 instead of 0, 1, 2, 3, 4, or instead of 10, 20, 30, 40, 50? Okay. So in this case, the numbers are arbitrary, and we don't want to pay any attention to them. So we need to identify the fact that the numbers we're using are really just an invention. It's just the scale that counts.